It is common that a piece of equipment has a residual value after it has been linearly depreciated over its entire lifetime. Part A. Find the rule for v of t, the value of a piece of equipment, assuming that the value of time t is equal to 0 is v subscript 0 and that the value after 20 years is r. So for part A, the first thing that I would notice is that we're talking about linear depreciation. Linear depreciation basically means that the value of a piece of equipment depreciates linearly over time, right? So each year there will be the same decrease of the value of this piece of equipment, right? There will be a steady value decrease, the steady amount decreased every year from the current value. All right, so now we have to find the rule. The rule basically says find the function for v, for the value of a piece of equipment, as a function of t. Right? That's what we're going to find. So now we have to realize that at time t is equal to 0, it says that the value is going to be the initial value, right? Which is v subscript 0. Now it says the value after 20 years is r, right? So that means when t is equal to 20, v, the current value of the equipment, will be r. That will be the value. So now, in order to find the function, as you can see, a linear function is given in the form y is equal to mx plus b. Recall that, right? So b serves as the initial value, in this case, v subscript 0. M serves as the slope that we're going to find using two ordered pairs here. And then x is going to be replaced with t, right? The variable t. And y, of course, will be the v, right? So this is going to be the v. This is going to be the t. Okay? So knowing that this is in the form of y is equal to mx plus b, we just have to substitute all the correct letters instead of the b, x, and y. We will be able to find the equation. But before we do that, let's find the slope, the m value. What is going to be the m value? The m value, right, and I'm going to say slope in parentheses, is going to be the change in y divided by the change in x. The y in this case variable is replaced by v, right? So the change is in v. So that means we have to subtract r minus the initial, right? So r minus v subscript 0 divided by the change in t, which stands for the change in x in the original xy plane that setting that you're used to see, right? So 20 minus 0, right? So as a result, the slope is equal to r minus the initial value of a piece of equipment divided by 20, right? So that's the slope. So in return, the function that shows the value of a piece of equipment as a function of t will be equal to the m, which we just found, which is r minus v, the original value of the piece of equipment, divided by 20 times now t minus, we can use any one of these, right? We can use any one of these. But the thing is, I'm trying to use the point slope form, but we don't need that, right? We don't need the point slope form because we actually know the initial value. The initial value was this, right? The v subscript 0. So that means we just have to multiply this by t, like the mx plus b format, and then add the b value, the initial value, which is v subscript 0. All right, so this is the rule that we found for v of t. So now we can use this rule, this function, in other words, that we've created. And notice that, make sure that you understand this t multiplies the r and then the minus v subscript 0 as well, right? T multiplies both of them, right? And they're not added. So maybe I might as well just show these as parentheses so you understand, just so that you're not confused. But even without parentheses, you will see notations like that when it's written even without parentheses. It's assumed that the t multiplies the r and then the v subscript 0. Okay, use the rule to find the value after 12 years of equipment, originally valued at $7,500, assuming that it has a residual value after 20 years of $500. So here's the thing. Now v as a function of 0, right, the initial value, v as a function of 0 is the same thing as v subscript 0. So v as a function of 0, it says now was valued at $7,500. Okay? Now also it says that v of 20, because it says residual value after 20 years is $500, so v of 20 is given as $500. So that means, what does that mean? That means the r value, because the r value was v, right? When t was equal to 20, the v was equal to r. So that means v of 20 is actually equal to r. Okay, so this is an important piece that we're going to use. So now we need to find the value after 12 years. So that means we need to find v of 12. So v of 12 will be found by using all of these that we have here, and we will be able to find it because we will have the t value, we will have the r value that we just found, we will have the initial value that we have as well, given based on part B. So there's really nothing unknown, right? So it will be a real number. That's why it's being asked here to find the value after 12 years. So now r value is going to be 500, right? Because v of 20 was 500, v of 20 is also r, right? So r must be 500. So it's going to be 500, substituting here, minus the initial one, which is 7,500, divided by 20. Let's use parentheses this time just in case, multiplied by the t. T is 12 in this case, right? It says after 12 years. That's what we subbed for the t value, right? This was t. So this must be 12. Okay, plus the initial, which is this, right? V subscript 0 is the same thing as v as a function of 0, v of 0, right? So 7,500. So what does that equal to? Let's see. This is equal to negative 7,000 over 20 times 12 plus 7,500. Okay, I'm going to do this without the calculator. I'm pretty sure it's doable. Basically, that's the same thing as negative 700 over 2 times 12 plus 7,500, which is basically equal to 350 minus 350 times 12 times 7,500. And I don't want to use the vertical multiplication, so what I'm going to do it this way. 10 plus 2 instead of 12 plus 7,500, which gives me minus 3,500 minus 700 plus 7,500. So what that gives me is, let's see, negative 4,200 plus 7,500. So that gives me 7,500 minus 4,000 is 3,500 minus 200 is 3,300. Right, so this is the value after 12 years. And I'm going to use a dollar sign just in case. Okay, this will be $3,300 is going to be the value of this piece of equipment after 12 years exactly, based on the given conditions provided. Thank you so much for watching. I hope this was helpful, and I'll see you in the next video.